On this page, we'll talk about confidence interval width. How wide is our confidence interval from the lower number that we calculated to the larger number? The goal of the confidence interval is to estimate the population proportion. If the interval contains the population proportion, a small amount of error means we have a more precise estimate. Narrower confidence intervals give more precise interval estimates for the population proportion, but this is only true if the intervals contain the population proportion. For a given standard error, a lower confidence level corresponds to a smaller margin of error. In general, 90% confidence intervals are narrower than 95% confidence intervals because there is a smaller margin of error. We are less confident that 90% confidence intervals contain the population proportion. Recall that in the long run, 10% of these intervals will not contain the population proportion at all. We therefore have to choose between precision and confidence. Of course, ideally, we would like to have a narrow interval and a high level of confidence, so we don't have to choose between precision and confidence. We can achieve this by increasing the size of the sample. So let's look at this example where we increase the size of the sample. College students and marijuana legalization. National surveys show that about 43% of American adults support the legalization of marijuana. What proportion of students at Skyline Community College support the legalization of marijuana? Let's suppose that students conduct two surveys. For one survey, they randomly sample 100 students. For the other survey, they randomly select a sample of 400 students. Surprisingly, in both surveys, the proportion in favor of legalization is 55%. The students calculate the 95% confidence interval for both surveys, for the 100 students and then for the 400 students. Okay, let's see. Let's calculate this. What is the impact of the size of the sample on the confidence interval? For the sample of size 100, the confidence interval is the sample proportion, which was 0.55 or 55%, plus or minus, okay, in this one, we're interested in 95% confidence. So we could use a 2 here. If you remember, it was P plus or minus 2 standard errors, but we're being more precise now because the z-score for a confidence level of 95% was precisely 1.96. But if you don't really need it to be super exact, you can always round it to 2. And then times that our favorite formula in the whole world, the standard error formula, square root of p, in this case p hat, because we don't know p, times 1 minus p hat, the sample proportion all over n, the sample size. So in the first one, there were 100 students, so that you see 100 in the denominator. But once we calculate it for 400 students, it's the same calculation because we still want 95% confidence. So it'll be the same z-score of 1.96. They said for both studies, 100 students and 400 students, that it was 55% as the sample proportion of those who favored legalizing. And then, the p hat is the same. There's just n that changes. So it changes the interval, just having the different n in the denominator of that square root. For n equals 100, a smaller sample size, you see the interval is wider. It goes from about 45.2% or 0.452 to 64.8% or 0.648. That's a wider interval than if we increase the number of students in our sample. The lower number was 0.501 or 50%. The higher number was 0.599. So it's between 45% and 65% is an estimate for only 100 students, which is kind of a wide margin. That's a 20%, the width of that confidence interval is 20% or 20.2. Whereas here we've narrowed it down more to 0.501, somewhere between 50% and 60%. That's only a 10% width, from 50% to 60%. So the larger sample size gives a smaller margin of error. This makes sense. Our intuition tells us that larger samples should give better estimates of the population proportion. We also know that sample size affects the variability in the sample proportions. Proportions from larger samples vary less. If there is less variability in the sampling distribution, the standard error is also smaller. Since we use the standard error to find the margin of error, larger samples will produce a smaller margin of error. In general, to decrease the margin of error, we can increase the sample size or decrease the confidence level. We always prefer to increase the sample size because it allows us to keep a higher level of confidence. We didn't have to decrease to 90% confidence in order to get a smaller margin of error. We want a higher level of confidence because the confidence level is the proportion of intervals that actually contain the population proportion.